In the name of God, hello dear students, welcome back to Ferho's website. My name is Masoud, I'm a physics teacher. Today we are going to uh, talk about the new subject, which is rotational motion of an object. Right, there is a phenomenon here, uh, let's say for better understanding the subject, I made these phenomena, I separated these phenomena to some questions. I dedicated 5 questions for this phenomenon for better understanding. Let me read the let's say action, and let me read the let's say event. There's an event actually. An event is taking place. The question explains the event, and during this, let's say during answering the question, I'll explain the phenomena gradually for you. A car approaching a curved exit ramp to the left. So there's a car. Firstly, the car follows a straight line path, and after that, the driver encounters a left, let's say, turn, right? It encounters a, let's say, turn to the left. It says, and at high speed, and the driver, let's say, drives the car at a high speed within a let's say within a turn, right? And it's very dangerous situation. I want you to slow down whenever you drive, especially when you encounter the turn. When you enter the turn, you have to slow down. You have to observe the situation uh, for providing the safety for you and for the others, right? In the figure below, so there's a phenomenon. The car's driver makes the sharp left turn. Why sharp left turn? Because the driver is very fast. He or she turns the turn at a high speed without slowing down. That's why it says, let's say, the driver makes the sharp left turn. Let's say the driver turns left fast. Use this phenomenon to answer the questions 1 to 5. Question number 1. What will happen to a passenger sitting beside the driver? So what will happen to the passenger? Imagine there's a passenger sitting beside the driver, and the driver, let's say, turns left. Whenever the driver turns left at a high speed, what happens to the passenger? Let me read the option for you, right? The first option, the passenger slides to the right. You see, the object, the car, turns to the left, but the passenger within the car slides to the right and hits the door. Wow. So maybe the person does not wear the seatbelt. That's why, let's say, he or she, let's say, slides across the seat and, let's say, hits the door. B, force of the door keeps the passenger from being ejected from the car. Force of the door. Teacher, does door have any force or not? Of course. Force of, I can say, normal force of the door. Normal force of the door in this situation keeps the passenger from being ejected. The door, let's say, tries to bring the passenger back to the circular track. So here, normal force of the door, right? Normal force of the door or reaction of the door against the passenger becomes a part of centripetal force. That's why in previous lesson, I told you centripetal force is not is a net force. Centripetal force is a resultant force. Mostly it consists of more than one force. You see here in this phenomenon that the door, let's say, helps the passenger, let's say, to return to its original, to return to his or her original circular track. That's why it becomes a part of circular centripetal force. That's why it helps the centripetal force, right? So we believe both, let's say, options. See, both previous options are correct. Till now is true, but don't hurry. Let's say I've told you over and over again that don't hurry. Read all options. After that, you decide. The passenger slides to the left. It's not true actually. If the passenger slides to the left, so uh, there's no problem actually for this situation. And the person, let's say, does not slide actually. So that's why the passenger does not slide to the left. The passenger slides to the right. That's why we don't accept this one and follows a circular path. Actually, A and B are true. So option C is true. Question number 2. The passenger hits the door because. Why the passenger hits the door? Because A, a mysterious outward force, centrifugal. You see, have you ever heard the word centrifugal or not? We haven't heard it before. That's why whenever you hear centrifugal force, reject it immediately. Don't accept it because our textbook don't believe it. Don't believe in centripetal force. That's why we don't accept it. But let me keep reading uh, keep reading it. A mysterious outward force, centrifugal force, pushes the passenger toward the door. We don't believe it. We ignore it. We don't accept it. B. There is not a sufficient frictional force between the passenger and the car seat. Maybe the friction is not enough. It's it makes sense actually. It makes sense. There's not a sufficient frictional force between the passenger and the car seat. It's true. Yeah. Say according to Newton's first law of inertia. Newton's first law has another name. It's called Newton's, let's say, law of inertia or law of continuity. Continuity or law of inertia, they are both used for Newton's first law. According to Newton's first law, the passenger tends to move in a linear motion. It's true, actually. The passenger, because at the beginning, you see, at the beginning there's a circular. At the beginning, there was a straight path. That's why the passenger, let's say, follows a circular path by means of his or her inertia, right? He or she follows let's say, a straight path. But whenever the, let's say, car reaches the turn and turns left at a high speed, that's why the person slides to the right because of lack of friction. This is the first one. And lack of friction leads to what? Lack of friction gives rise to the overcoming the inertia. So inertia overcomes the friction, and that's why the passenger slides to the right. And the passenger, keep in mind that whenever the car turns left, the passenger slides to the opposite direction, which is to the right. It doesn't. He or she does not slide to the same direction as the car, right? He or she, passenger, beside the car's driver, slides to the, let's say, opposite direction, not the same direction. Keep in mind. According to Newton's first law, I told you, of course, it's true. The passenger tends to move in a linear motion. B and C are correct. Yeah. Only centrifugal force is not correct. Don't believe, let's say, don't use it, and don't, let's say, don't circle it. Question number 3. Let me read the other question for you. Question number 3, it's about the phenomenon as well. Still, question number 5 is about the phenomenon. Question number 5, it says, why does the passenger slide across the door to the right? So we look for the reason of sliding the passenger to the right. Why doesn't it, let's say, slide to the left? Why does the passenger slide to the right? Let me read the option for you. A, because inertia of passenger overcomes. Nice. Inertia of the passenger overcomes the centripetal force of the car. Actually, there's a mistake here. I'm gonna correct the mistake. I have to say passenger, not the car, because the question, let's say, talks about the passenger. It doesn't talk about the car. That's why let me read the option for you again. A, because inertia of passenger overcomes the centripetal force of the passenger. It's true. Inertia controls the situation. Inertia wins the race, right? Because centripetal force or frictional force here is not enough to keep the passenger in a circular track. That's why, let's say, inertia controls the situation. B, because of Newton's first law, natural tendency of passenger is to continue moving in a straight line. True, straight, nice. Newton's first law, according to Newton's first law, natural tendency of passenger is to continue moving in a straight line. It's true. Because at the beginning, I told you, the car, let's say, we're moving in a, the car was moving in a straight line. That's why the passenger tends to be in a straight line, according to Newton's first law, law of inertia. See, both previous options are correct, right? It's true. But let me read the last option. A mysterious outward force, centrifugal force. I told you, we don't believe a centrifugal force because our textbook doesn't believe it, right? That's why we don't accept it. Pushes the passenger toward the door. That's why the only answer is C. C means both options A and B are correct. Question number 4. Let me read the question number 4 for you. It says the origin of the force that maintains circular motion of the passenger is. The origin of the force that maintains circular motion. We have two options, inertia or friction. Or I can say the origin, or which one is in charge of, which factor is in charge of maintaining the passenger in the circular path. Actually, friction. Of course, friction is a friction here is a centripetal force, right? Friction is a centripetal force. Number 5, space keeps the passenger from being ejected from the car. Space keeps the passenger from being ejected. It prevents the passenger from ejecting. Which factor prevents the passenger from ejecting? Of course, friction as well. Friction, let's say, keeps the passenger, let's say, calm. Friction keeps the passenger, let's say, to follow a circular track. But inertia, of course, tends to eject the passenger. Actually, inertia tends to eject the passenger from the circular track. So we finished the questions about the figure, actually about the phenomena. Question number 6. A girl at the state fair swings a ball in a vertical circle at the end of the string, right? The force of the string at the bottom is. So this is the question of preliminary exam. Let me examine it for you. There's a string and the girl swings the ball in a vertical, let's say, direction, in a vertical circular track. So at the bottom, it says at the bottom of the track. Let me draw it for you. There's a circular track at the bottom. There's a ball actually. The ball right now at the bottom is located at the bottom of this circular track. Let me read the option. And this is the question of preliminary exam. It says force of the string. What does it mean, force of the string? It means Ft, or centripetal force. Force of the string at the bottom. You see, at the bottom of the path is less than the ball's weight, greater than the ball's weight, equal to the weight of the ball, 0. Actually, Ft never becomes 0 unless the string breaks. So in the case of breaking the string, no problem, Ft becomes 0. But in this situation, when a string does not break, so this option does not make sense, right? We don't accept it. But here, so we are, let's say, doubtful about 3 options, A, B, and C. We don't know how to, let's say, guess the answer. I'm gonna give you a key for, let's say, for recognizing the true answer in a split second. How do you, let's say, how do you guess the correct answer actually? Let me tell you. At the bottom of the path, always Ft is greater than Fg. Keep in mind that at the bottom of the path, always tension of the string is greater than the weight of the ball. Fg means weight of the ball. So which option is true? At the bottom, Ft is less than the ball's weight? No. Greater than the ball's weight? Yes. So this option is true. Let me answer another question. A girl at a state fair, the same thing, but with a little bit difference. A girl at a state fair swings a ball in a vertical circle at the end of the string. The force of the string at the top, right, at the top of the path is Ft at the top is it less than the ball's weight? Is it greater than the ball's weight? Is it equal to the ball's weight, or is equal to 0? So let me draw it for you. Let me draw it here. I'm gonna draw it here, right? There is a string. Actually tied to a ball, and the ball right now is at the, at the bottom. I had to draw it at the bottom, at the top. So there's a circle track, and this is a ball, right, at the top of the, because it's at the top. We look for Ft at the top. Which kind of relationship is there between Ft and Fg? Ft of the string, Fg of the ball. Ft means weight, Fg means weight of the car. So right now, keep in mind that at the top of the path, always Ft is less than Fg, always. It doesn't change. So which option is true? A is true, because Ft is less than the object's weight, or ball's weight. Question number 8. Let me read the question number 8 for you. Question number 8. Figure below shows the ball attached to a string and swung in a vertical circle. Choose the correct option from the following. Actually, I prepared, let's say, 4 questions have to do with the previous phenomenon, with swinging the ball in a vertical track, for better understanding. Right now, so they are similar to the previous question, but I, let's say, prepared it graphically, right? I drew some figures for you. Let's discuss them together one by one. Figure below. So it says choose the correct option. Which option is true? I told you. Let me, let's say, jog your memory about the ball located at the bottom of the circular track. I told you, whenever the ball at the bottom of the circular track, always Ft is greater than Ft is greater than Fg, always. And I'm gonna add one more equation for you, I can say Ft is equal to Fg plus Fc. Fc means centripetal force, and Fg means weight of the ball. So keep in mind that this equation, these information work here. We have an inequality and we have an equation. Ft is greater than Fg at the bottom, and at the bottom, Ft is equal to Fg plus Fc as well. So which option is true? A, Ft is greater than Fg. Right. B, Ft is equal to Fg. We don't believe it. It's not true. C, Ft is less than Fg. No, it does not happen here. D, Ft is greater than and equal to Fg. No. So the only answer is A. Ft is greater than Fg. Let's move on to question number 9. We have another figure, but the ball located at the top of the path. Figure below shows the ball attached to a string and swung in a vertical track, vertical circle. Choose the correct option from the following. Let me, let's say, jog your memory. I'm gonna add one more information here. Whenever you observe a ball at the top of the circular track, you have to say Ft is less than Fg. That's the first one. I told you at the beginning of the, whenever we discussed the question, the previous question, I told you, I'm gonna add an equation for you. I say here at the top, Fg means weight of the ball is equal to the summation of Fc and Ft. So Fg is equal to Ft plus Fc. You see? So here let's say Ft is less than Fg. Fg becomes a summation of Ft and Fc because Fg is greater. But in the previous case, Ft was summation of Fg and Fc because Ft was greater. So anyway, so right now, we focus on, let me, no problem. We are here, right? The ball located at the top of the path. Let me read the option. A, Ft is greater than Fg. No, it's wrong. At the top, Ft is less. We don't believe this one. B, Ft is equal to Fg. It's wrong. C, Ft is less than Fg. It's right. It's true. D, Ft is less than and equal to Fg. No, it's not true. So only C is true, right? Let me read one more question. Question number 10. Question number 10. We are about to finish the lecture, finish the lesson. Only these two questions are remained for finishing this lesson. And I'm gonna appreciate you for being with us. Question number 10. Figure below shows the ball attached to a string and swung in a vertical circle. Choose the correct option from the following. So which option is true? Ft is greater than Fg. Yeah, at the bottom, Ft is greater than Fg. Ft overcomes Fg. It's true. B, Ft is equal to Fg plus Fc. Yeah, it's right. Because I told you at the bottom, Ft is equal to summation of Fg and Fc. So till now, A plus B means both previous options are true, but the last one, D, Ft is greater than or equal to the Fg. No, we don't believe it. It's not true. So the only answer is this one, C. Two, let's say options are true. The last question for this lesson, figure below shows a ball attached to a string and swung in a vertical circle. Choose the correct option from the following. At the top. So at the top, Ft is less than Fg. And Fg is the summation of Ft and Fc. Keep in mind. So Ft is less than Fg. It's true. We believe it. B, Ft is summation of Ft is equal to Fg minus Fc. You see, it rearranged the, let's say, equation. I wrote this equation for you. I said Fg is equal to Fc plus Ft. right, at the top. So right now, I want you to rearrange the equation for ft. ft becomes what? ft becomes fg minus fc. So it's true, right? C is equal A plus B, means both previous options are true. D, ft is less than and equal to the fg. No, we don't believe it. So A and B are true. I appreciate you guys for being with us. Thank you very much for watching this video, and bye-bye.